everyone. I hope you're all having a great day. This week we're going to be talking about our very last transformation, and that's going to be dilations. So dilation is a transformation in which a figure is enlarged or reduced. So it makes the shape larger or it makes it smaller. And so for instance here we have a triangle PQR. This one was enlarged to become P prime, Q prime, and R prime. And so to dilate a figure we need to have a scale factor, and we labeled this as K. And the scale factor is a ratio of the lengths of corresponding sides of the image and pre-image. So for example, if I'm looking at this picture, the scale factor here, K, could equal to CP prime over CP. Another way I can think about it is that the scale factor is the image length divided by the actual length, or the original. In other words, the image divided by the pre-image. And the center of dilation is a fixed point from which the figure is dilated. So this would be my center of dilation, the C. And so we have coordinate rules for this as well. So this would be kind of similar to translations. Translations we added or subtracted. This one we are going to be multiplying. And so it would be xy to kx, ky. And so that means they're being multiplied together. And so again, we have two different types. We have an enlargement, and that's going to be whenever my scale factor is bigger than 1. So for example, if k is equal to 2, my coordinate rule there would be xy to 2x, 2y. A reduction, on the other hand, that one is going to be any number between 0 and 1. So for example, if k was equal to 1/2, and so this would make the shape smaller. So if k is equal to 1/2, my coordinate rules would be xy goes to 1/2 x, 1/2 y. So let's go ahead and look at this in an example of this. So going back to the Mona Lisa example, here k is equal to 1. If k is bigger than 1, I see the Mona Lisa gets much bigger. If I make the Mona Lisa smaller than 1, I see it gets smaller. Now let's look at what happens when it's negative. So if I go to just -1, I see it kind of flips around right there. And so every time it's negative, it's still going to get bigger or smaller depending on whether it's between 0 and 1 or bigger than 1. But the negative is just going to flip it upside down. And so we'll see that in some later examples. But that's it for this video. Go ahead and move on to the next one where we'll be talking about identifying dilations.